All right, decimals. When you say decimals, what you're really saying is decimal fractions. Decimal fractions are a shorthand way of writing fractions whose denominators are multiples of 10. You use decimals all the time, whether you're thinking about it or not. Whenever you talk about money, if you have $5.23, remember that there's 100 pennies and a dollar. So you're really saying 5 whole dollars and 23 1/100ths of a dollar. All right, let's look at $5.23. This number 5, the number to the left of the decimal point, represents a whole number. So any number left of the decimal point is a whole number. The numbers to the right of the decimal point represent the fractional part of the number. So that part is less than one whole. So you can think of this as a mixed number where you have a whole number and a fraction. All right. Recall that when you have a 1 in the denominator, like 5/1, that's equal to 5 because that's 5 divided by 1. 5 divided by 1 is 5. So if you're dividing by 1, you have a whole number. So let's look at this decimal fraction, 27.39. So the 27 is to the left of the decimal point. So if you thought of this as money, that would be 27 whole dollars and 39 1/100ths. So let's write down the place values for each of these numbers. We'll say it first. You have 7 ones, 2 tens. So that 7 you can think of as the 1ths place. If you're dividing by 1, you get a whole number. The 3 is behind the decimal point, so that's the 10ths place. And then the 9 is the 100ths place. Remember, this represents 39 cents, and there's 100 pennies and a dollar, so this is 39 1/100ths. Let me write down those place values. That's ones, tens, then after the decimal point, it's tenths and hundredths. So think of this as a mixed number where you have 27 whole dollars and 39 1/100ths, because that's the hundredths place. Let's look at another example. So there's your decimal point. The numbers to the left of the decimal point are whole numbers. So this is simply 513. And then here we start with the tenths place, hundredths place, and then the 7 is in the thousandths place. Let me write those places for you. So this is the hundreds place, and you might want to notice the difference in spelling. 100 is a whole number. Hundredths with a TH, that's over 100. So this is tenths, hundredths, thousandths place. So this is a mixed number where you have 513 as the whole number. And then this is 217 thousandths. So that's over 1,000. Let's look at another. So this is 9.2531. So the 9 is the whole number. 2 is in the tenths place, hundredths, thousandths, and 10,000ths place. I'll write that down for you. So this decimal fraction is a shorthand way of writing this mixed fraction, 9 and 2531 over 10,000. So there's two ways of writing a decimal as a fraction. You can either count off, like we've done here, tenths, hundredths, to know what number goes in the denominator. And kind of a shortcut, the number of digits behind the decimal point is the same as the number of zeros behind the 1 in the denominator. We have 2 digits behind the decimal point, 2 zeros in the denominator. Of course, you have to have that 1, because otherwise it's just a 0 and not a multiple of 10. Here we have 1, 2, 3 digits behind the decimal point. So in the denominator, we have the 1, and then 1, 2, 3 zeros. And here we have 1, 2, 3, 4 digits behind the decimal point. So there's 1, 2, 3, 4 zeros behind the 1 in the denominator. So if you want to write a decimal as a traditional fraction, all you have to do is notice how many places are behind the decimal point, or count off. That's tenths and hundredths. So you'll notice 3 is in front of the decimal point, so that's your whole number. And we put 100 in the denominator. And you wouldn't say I have $4. You would just say I have $4. All right, this is the mixed number. Last chapter, we learned how to convert this into an improper. So it's just 3 times 100, which is 300, plus 4. So that's 304 over 100. Or you could think of it this way. You just write the same number with no dot. You don't put the dot in the fraction, but then you put it over the denominator. So tenths, hundredths, that would just be 304 over 100. All right, this would be a good place to hit pause and write this one as a mixed number, and then write it also as an improper fraction. All right, so 5 is your whole number. Then you count the number of places behind the decimal point. So that's tenths, hundredths, thousandths. So the denominator is going to be 1,000. And the numerator is going to be 23. So you could either convert this to an improper fraction the regular way. 5 times 1,000 is 5,000, and add that to 23. Or you can just think of it this way. You write 5023, no dot, over 1,000. All right, let's just do 3 more examples. So this would be a good place to hit the pause button and then write this as a mixed number and an improper fraction. So why don't you hit pause and try that. All right, this one is 12. That's the whole number part. Then you count tenths, hundredths, thousandths. So that's 1,000 in the denominator and 31 in the numerator. The mixed number. And then for the improper, remember the denominator always stays the same when you convert from a mixed to an improper. And you basically just write this number with no dot. Or convert it the old-fashioned way. 12 times 1,000 is 12,000 plus 31. All right, 3 is my whole number. And then you count tenths, hundredths, thousandths, 10,000ths place. And we just put the 29 up there. Let's write that as an improper. It's pretty simple. The denominator is going to stay the same. So it's 10,000. And the easy way is just write this number with no dot. Or simply convert this mixed number to an improper. 3 times 10,000 is 30,000, and add that to 29. All right, 4 is my whole number. And then we count tenths, hundredths, thousandths, 10,000ths, 100,000ths. And then to rewrite that as an improper, the denominator stays the same. And you could just write this number without the dot or convert it. 4 times 100,000 is 400,000 plus 7. All right, let's look at some decimal fractions that are less than one whole. If it's less than one whole, then there's a 0 in the whole number part. So there's no whole. We just have a part. So that's the tenths place. Remember, there's no oneths place because if you divide something by 1, you get a whole number. So that's the ones place. So tenths, hundredths. This is just 3 over 100. This is less than one whole, so it's a proper fraction. And remember, an improper fraction can be written as a mixed number, but a proper fraction is less than one whole. There's no whole number part, so there's no way to write this as a mixed number. All right, why don't you hit pause and try writing these two as a fraction. All right, so we count tenths, hundredths, thousandths. So the denominator is 1,000. And then you just write the 27. Remember, you wouldn't put the 0 in front of it. That would be like saying, I have $27. All right, and then this one, tenths, hundredths, thousandths, 10,000ths. And that's how you write that one. All right, let's go the other way. If you have a fraction whose denominator is a multiple of 10, how do you write that as a decimal fraction? Well, you just write the numerator. You count the number of zeros in the denominator. There's 1. You start at the right, and you move the decimal point that many places. And then if there's nothing in front, you put a 0. So here you would write the 17. You count 1, 2, 3 zeros in the denominator. So you start at the right, you go 1, 2, 3. And if you have an empty scoop, you put a 0 in there. And if there's nothing in front of the decimal point, you put a 0. You can check this by counting tenths, hundredths, thousandths. We have 1,000. If you want to hit pause and try this one on your own, that would be great. So you write the 29. You count 1, 2, 3, 4. So we start at the right. 1, 2, 3, 4. That's where your decimal point is. Fill in the empty scoops. And if there's no whole number, put a 0. Let's do a couple more. All right, let's write these three examples as decimals. And this would be a great time to hit the pause button and try them on your own. All right, so we write the numerator. You count the number of zeros in the denominator. So there's 1, 2. Start at the right. Go 1, 2. That's where the dot goes. You'll notice this is more than one whole. And that makes sense because we started with an improper fraction. Let's try this one. You write the numerator. Count the number of zeros in the denominator. 1, 2, 3. And again, that makes sense. You get a number bigger than one whole because we started with an improper fraction. Count 1, 2, 3. Start at the right, go to the left. 1, 2, 3. 27 and 53 thousandths. All right, before we add or subtract decimals, we need to talk about equivalent decimals. You probably remember when we talked about fractions, we had equivalent fractions. So if you ate a half of a pizza, that's the same as eating 2/4 of a pizza. So equivalent fractions represent the same quantity. Well, equivalent decimals represent the same quantity as well. So is 0.7 the same thing as 0.70? Let's write both of those as a fraction. This is 7/10. And this is 70 over 100. Well, you can see that if you reduce 70 over 100, it's the same thing as 7 over 10. So 0.7 and 0.70 are equivalent decimals. What if you had 0.700? Well, the answer is yes, because that's 700 over 1,000. And if you reduce that fraction, you still get 7 over 10. So one thing you might notice is that for each of these, the 7 is in the tenths place. And then you've got these zeros after it. So all of these are equivalent decimals. And this is a handy thing to know when you're doing operations with decimals. If you need more decimal places, you can just add zeros at the end and you're not changing the actual number. All right, let's look at some decimals that are not equivalent. So first, what do you think? Is 0.3 the same thing as 0.03? Let's write those as fractions. Would you rather have 3/10 of a cake or 3/100 of a cake? I would rather have 3/10 of a cake because you can see that that's more cake. So these decimals are not equivalent. So if you put zeros in front of the non-zero digit, you change it. You can also see that here the 3 is in the tenths place, here the 3 is in the hundredths place, and here the 3 is in the thousandths place. So these are not equivalent. You probably already know how to add decimals if you deal with money. You just take the two numbers and you line up the decimal points. And the decimal point in your answer will be in the same place. So 5 and 0 makes 5, 2 and 3 makes 5, 5 and 1 makes 6. So $5.25 plus $1.30 is $6.55. So you just line up the decimal points, and the decimal point in your answer is in the same place. So if you want, you could hit the pause button and try this one. All right, so it doesn't matter if they have the same number of decimal places to start with. You just need to line up the dots. And then I like to make it beautiful. So you can use graph paper. You can just put your own columns in there just so that things don't get mixed up. And if you want, you can fill in zeros, or you can just say 1 and nothing is 1. 5 and 7 make 12, carry the 1. 1 and 3 and 0 make 4. 1 and nothing makes 1. Bring down the dot, and then bring down the 2. All right, let's do this subtraction problem together. So we have 17, and we're going to take away 3/100ths. And you're probably wondering, well, where's the dot? Well, if you have a whole number, there's a dot at the end of it. Just put it right there. And we line it up. And then you're wondering, well, what do I take the 3 out of? Well, since there's nothing there, this is when we use that idea of equivalent decimals. So you can just fill in as many zeros after the decimal point as you want. And then subtract, and there's more than one correct way to do this. I like to think of it as taking 1, and some people like to make this a 10 and a 9 and go borrow, borrow, borrow. I like to just think of this as 70, and if I take 1 out of 70, that's 69. But yeah, you can do it in a way that works for you. 3 out of 10 is 7. Nothing out of 9 is 9. Bring down the dot. Bring down the 6 and 1. Let's try another one. All right, 29. Take away 0.0034. So this would be a good time to hit pause and try this one on your own. All right, so 29 is a whole number, so it has a dot at the end. 0.0034. We're going to take away. So I have nothing to take it out of. So I'm going to fill in with zeros. And you can either do the borrow, borrow, borrow thing, or I like to think of it as taking 1 out of. I just go until I hit a non-zero digit. So if I take 1 out of 9,000, I get 8, 9, 9, 9. 4 out of 10 is 6. 3 out of 9 is 6. 0 out of 9, 9. 0 out of 9, 9. And let's try one more. All right, 3.8, take away 54 10,000ths. So this would be a good time to hit pause and try it on your own. We have 3.8. And we can use that concept of equivalent decimals to fill in zeros. And then you can either do borrow, 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 or I like to think of it as I'm taking 1. I just go over to the next non-zero digit, take 1 out of 800, and I get 799. 4 out of 10 is 6. 5 out of 9 is 4. Nothing out of 9. 9. 7. Bring down your decimal point. And that's it.